Good afternoon, and thank you for joining us for our webinar today on Simplified Computing Anywhere with HyperFlex and Cisco Intersight. My name is Pete Robertson. I'm a specialist sales engineer with AHEAD, and I've had the privilege for the last 3.5 years to work with a great team of colleagues at AHEAD and to work with fantastic customers, helping them with digital transformation initiatives. I focus primarily on networking technologies and helping organizations understand how networking is not only critical to cloud adoption and digital transformation, but can also be a significant change agent, bringing a lot of benefit to the organization and drive a lot of initiatives that IT is supporting. But my background is in data center architecture, and I am excited today to spend time talking with you about HyperFlex, Cisco's HyperConvergence platform, and the differentiators they have when they combine it with Cisco Intersight to bring orchestration and global management to their platform. Our agenda for today is fairly brief. I want to make sure that we get through some of the slides here in the first half of this presentation because I'd like to get to doing a live demo. So we're going to look briefly at the evolution of compute and how Cisco really came about bringing HyperFlex to the market. We'll do a brief overview of HyperFlex. This is by no means a deep dive into the technology today. If that is something that interests you as a follow-up to anything that we cover in today's session, then please feel free to reach out to us and let us know. We would be happy to facilitate a follow-up on any of the technologies or solutions that we discuss in this webinar. We're also then going to cover the simplified management that Cisco Intersight provides not only to HyperFlex, but to the entire Cisco UCS portfolio and to third-party solutions that are starting to be integrated into that platform. And then, as I said, we're going to wrap up with a demonstration of both HyperFlex and Intersight. Now, feel free at any time to ask any questions throughout. You can use the chat window there in your webinar portal, and we will be monitoring those, and I will either respond as we go, or we will be answering any remaining questions at the end of today's session. So as we jump into looking at on-premises or private cloud computing infrastructure, historically over the years, there's really been 4 ways of approaching how we would think about providing compute to the business. And the first approach, the most common approach going back 20, 30 years was just to do it yourself, right? You had a number of choices as to solutions. You had a number of choices as to manufacturers, whether it's IBM, Dell, HP, whether you were going to do bare metal or bring in some form of virtualization solution. You were responsible in working with your partners to evaluate all of the choices of solution that were available to you, what would be the best solution for your business, what meets your requirements, and then stitching that together, because data center has always been a combination of compute and storage and networking and security and all of the management tools around that to manage that infrastructure. And you were responsible for evaluating each of those components and determining how to stitch them together to build the infrastructure to provide compute capabilities to your business. And that was a challenge for a lot of organizations. They didn't have the human resources or the time to continue to do this ongoing research about what is the right solution and how do we size it and integrate it correctly. So reference architectures, the second here on our list, became very popular as a way of streamlining that selection process. It was validating which components from multiple vendors or a single vendor that integrate tightly to provide a certain level of performance, a certain level of capacity, and to facilitate a compute platform for your organization. And those became very popular indeed. But for some organizations, that still didn't go far enough. They didn't just want recommendations and a reference architecture on how to build a solution for their organization. They actually wanted to have that delivered. They wanted to have it sized, built offsite, and brought into their organization so they could get it up and running as quickly as possible, minimize any build time, and get time to value extremely accelerated. So that's where converged infrastructure came in, and we're talking about solutions like vBlocks or FlexPods that either the manufacturer or distributor or partner would configure to suit the individual customer and then deliver to the organization and get it into production very quickly. Now, more recently, in the last 2 years, you've heard a lot of talk in the industry around hyperconvergence. And the reason for that is all of these previous types of architecture, whether it's converged, reference, or do-it-yourself, are all built around the common data center building blocks of compute, storage, and networking. And we would also have to realize that given the challenges we have around sizing and procurement and budget, we would often do things like size a storage array for the next 3 to 5 years of anticipated growth and make a large capital investment up front and hope that the performance that it provides and the capacity that it provides is sufficient for that forecasted period. And that isn't very flexible. It doesn't give the business the opportunity to respond to changes in direction, to handle new initiatives, or to be agile when it comes to providing the appropriate type of infrastructure to support the demands of the business. So hyper-converged infrastructure, as we're going to look at today with HyperFlex, breaks that traditional three-tier model, and instead of having to size everything up front, gives us small cookie-cutter units of compute where we integrate storage compute, and in this case with HyperFlex, networking, into small consumable chunks that we can purchase and scale out on demand, making the whole environment and approach to providing data center architecture much more granular and flexible. So when we talk about this, and on the left here is what I've been mentioning so far, this traditional approach to infrastructure. You can see the blue box there, storage, and then compute and network. And at the top, obviously, we have a whole suite, a gamut of management tools. They may be ones that you purchase from a third party to give you a more pervasive view of your data center or to manage multiple products, or they may be tools that are provided by one manufacturer just for their solution. There's typically tooling sprawl in these type of environments. Now, before we get to hyperconvergence, back in 2009, Cisco stepped into the server market, and a lot of people were skeptical at this at first. How could a network giant step in and compete with such a competitive industry along with HP and IBM? And yet they didn't have any technical debt or legacy customers that they had to support. So they had the luxury of saying, how do we do computing right for the 21st century? And they really brought three significant transformations to the compute industry at this point. The first, as you see there at the bottom, is they tightly coupled computing and networking. Instead of it being completely separate, they realized that so much of providing compute to the business was dependent on how it integrates with the network, both from an Ethernet perspective and with a storage network, so that back-end persistent storage. If we can tightly couple those, we provide a great more deal of flexibility and performance to the business. But the real benefits came in the fact that they abstracted the identity of each individual compute server into a software abstraction and as a service profile, essentially providing software-defined compute. And that is a significant benefit that didn't exist and still doesn't exist in any other competitive solutions, that we can define our server identities in software, and we can do that through APIs and automation, and then we can apply that to hardware. And instead of being dependent on what the hardware manufacturers have given us when we buy something, we can control and manipulate those identities to suit what we're trying to build for our business. The third thing that they gave us was the ability to start to bring management more tightly integrated to the platform. Hybrid cloud management was starting to become a common thing at this point, where we're looking at having tooling to allow us to leverage automation or single pane of glass management for distributed silos of infrastructure, and public cloud was starting to come in there as well. Now, what we're talking about today is hyperconvergence. And with HyperFlex, we're really taking all of those things and we're bringing them into one engineered solution. It has baked-in management designed specifically for managing HyperFlex, for managing the compute and the network and the storage. It's all integrated into the solution. So we bring it all together and we provide a solution that is scalable, that it performs very well, and yet is engineered from the ground up to be a tightly integrated and simplified solution. Now, at the core of any hyperconverged solution is a software-defined storage layer. And for HyperFlex, that is the HyperFlex data platform. And I'm not going to spend a lot of time focusing on this today. We're going to go through it fairly quickly. But the key components of this software-defined storage layer and what differentiates HyperFlex from the other solutions in the market is that it is a highly distributed file system. Not just in terms of the fact that data gets written to multiple disks across multiple nodes within the cluster, but writes are distributed across all the nodes and disks in the cluster, making HyperFlex still to this date significantly higher in terms of performance than any of the other hyperconverged solutions on the market. And built into that data layer are also advanced services that typically would have been additional licensed costly functions of a typical storage array, things like data optimization, compression, dedupe. These are now built in and standard features of that data layer that is provided by the HyperFlex data platform. And it was designed from the ground up to be ready for future workloads, such as containers and cloud-native applications. And Cisco has recently made some announcements about natively supporting containers on top of Cisco HyperFlex. So again, hyperconvergence is about using a unit of compute. In this case, it's a rack mount server that has local disks and CPU and memory inside of it. And I'm just showing one here on the screen. Now, there will be some form of boot partition that exists on this server. In the case of HyperFlex, it's an SD card, and that is used to boot the hypervisor. All of these platforms rely on having a virtualization provider on top. And here I'm going to show vCenter. HyperFlex will support vSphere as well as Hyper-V. So that hypervisor boots up when the server is powered on. And when that hypervisor is fully loaded, it also powers on a virtual machine. And that virtual machine, its disk space is on a dedicated SSD where that controller VM resides. So this is a virtual machine that is going to be pinned to this one host. It never moves off of it, and it serves a specific function. It has direct access to all of the other disks in that underlying server. So it boots off the SSD, and now it has direct access and management of the remaining disks in that physical server. And those could be spinning disks, SSDs, or NVMe. And what that controller VM does is that it pools that data and provides it up into the software-defined storage layer, providing striped access to the data across all the nodes in the cluster. And the IO Visor module that you see here on the screen is a service, a module of that VM that is providing that distributed service, that's providing distributed reads and writes, that is responsible for the dedupe features that are going on in the data platform. And that is there and allows this to be viewed to the hypervisor and then to other VMs that you deploy on top of it as a consistent single data store, even though it is comprising under the hood of disks across multiple physical nodes. So again, here, the hypervisor will present a traditional data store, and on top of that, you would actually deploy your workload VMs. So all of the data services are offloaded to that software-defined storage layer, and on top of that software-defined storage layer, we can present traditional data stores to the hypervisor. So again, speaking about how this is designed to scale out so that we don't need to purchase upfront 5 years of estimated performance and capacity needs, here I'm showing 3 servers. And again, you can see now that the red HyperConverged data platform or HyperFlex data platform here is essentially shown as the pool of both capacity and performance across those 3 nodes. Now, at the bottom here, I'm also showing a pair of Cisco Fabric interconnects, and we'll talk about that. That's, again, another significant differentiator of the HyperFlex solution. But if we want to scale out this solution, we simply purchase another node. And as soon as we connect that node in and it comes online, the system automatically takes advantage of the capacity and performance that that node provides and expands the capabilities of that software-defined storage layer. I can add another server and I can keep scaling up. With HyperFlex, you can currently scale up to 32 nodes in any one cluster. Now, if it comes to a time where I need to do maintenance or I want to take something out of production, I want to decommission a server because it's reaching its end of life, then I take advantage of the capabilities of the hypervisor to move the workloads on a given node off to other hosts in that cluster. And then once they are fully removed and there's no running workload, I can decommission that server. And that is a completely non-disruptive, transparent process to the actual user workload, the VMs that are running on top of this hyperconverged platform. And I said a little bit earlier on around how the distributed data distribution model of the HyperFlex data platform is one thing that makes it unique compared to its competitive solutions. And if you see on the screen right now, I'm kind of reflecting one of the competitive solutions, or how other HCI solutions typically work, and that is that over here on the left, one of these 3 VMs will have written to its local disk on its local server on which it's running. And after the fact, as a post-write process, the controller VM then, as you can see these arrows here, is then going to replicate that data onto the other nodes to make sure there's data resiliency and the data exists in more than one place. But that initial write is just to the local disk of the host on which the VM is running. And it's a post-write process to distribute it. This causes performance hotspots, and it is a slower overall commit than if it was written in a distributed fashion, which is what HyperFlex does. So by comparison here with HyperFlex, when a VM writes, that write is intercepted by the IO visor and distributed across all the controller VMs. So the write is synchronous to each of the nodes in the data platform. This is what allows us to have extremely fast writes in a distributed manner, no performance hotspots. And that is why, as we'll see later on, when it comes to IOPS and storage performance, HyperFlex is always significantly ahead of its competition. Now, again, some of those services we talked about that are built in, these would normally be advanced features on traditional storage arrays. They're built in and turned on by default. You get compression and you get dedupe without any need for special hardware, no performance impact. It's all in line. It's not a post process. And all of this comes in the base license. There is no additional cost. So again, you get some of these services that bring value to the business as part of the base solution. Now, again, we talked about the fact that HyperConvergence is being adopted because it's a simplified approach to providing compute to the business. And the topic for today's webinar is that HyperFlex provides you with simplified computing, and that starts with how you procure and provision. So with HyperFlex, the software, your chosen hypervisor, in this case I'm showing on the screen again, VMware vSphere, and that HyperFlex data platform is pre-staged onto the servers, onto the hardware by Cisco when they manufacture these boxes. So before they even ship to your site, they have the necessary software installed on them. So when they arrive, you're simply going to take them out of the box, you're going to rack them, you're going to cable them up, and we'll talk about that here in a little bit because there's two different choices as to how you would do that, and you will power it on. And as soon as it's powered on, if it's connected to a Fabric Interconnect, that's what's known as a HyperFlex core deployment, traditional capabilities of Cisco UCS are going to then inventory that server, know its capabilities, know that it's a HyperFlex node, and give you the option to say, do you want me to add this to an existing HyperFlex cluster, or do you want me to create a new cluster? And all of the validation and checks is done because of the fact that UCS Manager has full visibility into the inventory of that server and to all of the attached devices to that pair of Fabric Interconnects. There's also the option of doing edge deployments where there is no pair of Fabric Interconnects, and we're going to focus on that towards the end of this presentation. And in that case, what it's going to do is as soon as you've powered it up, as long as it can get a DHCP address and call home to Cisco's cloud, again, it then is available for you to consume and to automate and orchestrate the construction and provisioning of a cluster. So all of that takes place extremely quickly. If it's a core deployment where you have Fabric Interconnects and 10 gig networking, the entire process from power on to having it up and running, ready to deploy VMs is typically less than 60 minutes, which is a significant improvement over the way organizations typically go about scaling out or bringing in net new compute platforms, bringing this down from weeks or days to just a matter of minutes. And again, there's a lot of automation built into this platform, not just because Cisco has engineered that as part of HyperFlex, but because the underlying hardware platform is UCS. And back in 2009, when UCS came in and shook up the server market, automation was a key part of that. UCS Manager component, that software-defined compute that provided abstraction of server identities into service profiles, provided an API and provided a PowerShell integrations back in 2009, and that's continued to be used. So when HyperFlex deploys a cluster and the automation and orchestration kicks off to build clusters, it's leveraging these consumable configuration policies, these UCS server profiles, to build these clusters. And that allows us to continue to provide role-based access control and maintain the separation of duties between the different subject matter experts within your organization. We can still have a server SME defining certain policies, the network SME defining the configuration components that are specific to their area of knowledge and responsibility, and similarly for storage. So these policies are defined, and then these policies get translated into these templates, service profile templates in the case of UCS Manager for core deployments, or in Intersight, as you will see later on in our demo, profiles for a HyperFlex cluster. Those in turn get instantiated into individual profiles that get bound to a single individual piece of hardware. So each individual node gets its own profile from which it then understands and is programmed into the hardware its identity. And that allows us to then push that into HyperFlex and build clusters, again, using software-defined compute and software-defined storage together to provide the value that HyperFlex is bringing. The proven capabilities, the transformation that UCS brings from a hardware perspective, coupled with the benefits that the software-defined storage layer brings with the HX data platform. And ongoing, not just from day one provisioning, but ongoing, the API of both UCS Manager as well as Intersight allows automation to allow us to do extremely interesting things. I don't have it as part of the demo today, but one of the compelling use cases for the edge deployment that we will show is that we can also orchestrate additional deployment, not only of the HyperFlex cluster, but of then actual workloads or network function virtualization components on top of it. So we can use Intersight, for example, not only to provision an edge cluster, but we could also have it provision network virtualized routers in order to connect that site into an SD-WAN network using Viptela. So the capabilities of the automation to then orchestrate not just the build out of the compute, but the connectivity of that compute into the broader enterprise network can all be done through workflows. So we talked about the fact that one of the differentiators of HyperFlex is that networking is part of the solution. And with the competitive solutions in the market, that's not the case. You have the compute node, the physical hardware, and you have that software-defined storage layer. But networking was always the customer's responsibility. Plug these nodes into the network, make sure the network's configured correctly, and then once that's done, we should hopefully be able to start things rolling. But the network's the critical piece here, right? The Ethernet network, the LAN, is now responsible for storage traffic between these nodes. It's no longer taking place on a fiber channel network. It's going over the regular network. So we needed to have things such as jumbo frames or IPv6 configurations for node discovery or multicast. And that was adding complexity that many customers were a little wary of and would often cause the deployment to be slower than it should be. Well, because the top-of-rack networking in a HyperFlex core deployment is the fabric interconnects, again, Cisco has the ability to control the configuration. So when you now say, I want to deploy a HyperFlex cluster, it's not only pushing down the server profile configuration to the attached HyperFlex nodes, it's also configuring the networking components of those fabric interconnects for optimal performance and ensuring that all settings are perfectly configured to ensure rapid provisioning and optimal performance in an ongoing fashion. And Cisco supports the whole thing. So there's no longer the risk of any finger pointing when it comes to troubleshooting down the road when you're in production. Cisco supports the entire solution because the network is part of the solution and not something that you're dependent on without any visibility into. Now, I talked a lot about performance. Just quickly want to show here a couple of charts from a third-party testing organization. We have tested and done bake-offs of all the different hyperconverged solutions in our own ahead lab, and we validate. We see very similar results here. But this was running the same SQL Server workload across a 4-node Cisco HyperFlex platform and comparing it with a 4-node solution from vendor A and vendor B. And as you can see here on the left, the blue bar, significantly higher performance in terms of IOPS from Cisco because of its distributed write model than what you're seeing from vendor A and vendor B. And what that translates to is if you wanted to get the same level of performance from the two other vendors, you would have to buy additional nodes because each node, again, contributes performance and capacity into the cluster. So for vendor A, you'd have to sell 10 nodes and vendor B 8 in order to get the same performance that you were seeing in a 4-node HyperFlex solution. So again, significant cost savings here based on the way in which Cisco HyperFlex handles data writes in a distributed fashion. Now, again, the topic of this webinar was simplified computing anywhere. And that's really where I think HyperFlex differentiates itself significantly. In the core of the data center, we've talked about using traditional UCS technology attached to fabric interconnects and the benefits that brings. But at the same time, we all recognize that the data center is no longer this core component of enterprise IT. Applications are getting extremely distributed, whether that's to public cloud, to SaaS, or increasingly to the edge of the network. Things like IoT are driving small compute cells. We still have to take into account that there will be applications that need to reside in the enterprise remote branch office, or there might just be SMB organizations that don't have a large data center footprint and aren't going to invest in the necessary infrastructure to support a core deployment with fabric interconnects and things like that. Cisco has made HyperFlex a standardized platform no matter what use case you need. So if you want it in your data center, you can use the same management tooling and the same software-defined storage layer running on top of HyperFlex attached, on top of UCS attached to fabric interconnects for a large data center deployment. But we still use the same management tools and the same hardware and the same benefits of the HX data platform if we're deploying on a 2, 3, or 4-node edge cluster, whether that, again, is in a branch office or in an SMB customer, without needing fabric interconnects, just using traditional networking to plug in 3 or 4 nodes to a network. And it is the common solution. It's not I choose one solution for my data center and choose another solution for my branch office. I can have the same standardized feature set no matter where I need compute. And that's a significant differentiator. So when we talk about HyperFlex Edge, this is without the need for fabric interconnects, just using regular switching, and it can be 1 gig switching or 10 gig switching. I can have just 2 nodes. Now, if I have 2 nodes, I need to have a witness, and I'll talk about that here in a minute because I don't want to get into a split brain scenario where they're fighting those two. Is the other node up and who's really in control? If I have a 3-node cluster, I don't need the witness service, and again, if I go up to a 4-node as well, that goes away. But I can start with the smallest 2, and I can scale up to 3 or 4 and still be within what's known as an edge deployment without the need for fabric interconnects. So I have the tremendous scalability here, and I can, again, provide the same benefits of a single solution, centralized management, as we'll see soon. I can still have the benefits of data optimization, compression, dedupe in an edge cluster where historically I would have to have said, well, is it worth me deploying a hypervisor out there? Or is it worth me putting in a small SAN just for a 2 or 3 node cluster? And here I can use HyperConvergence to meet my high availability and performance needs, even though I have a very small use case in the edge. So this is where Cisco Intersight comes in, because if we start to adopt this model and say, I see the value that HyperFlex brings, and I want to use it for both my edge and my core, especially if you're a large organization, I'm now going to start having a very distributed deployment of Cisco HyperFlex. I may have it in my data centers. I may have 5, 10, 100,000 remote sites where I start to put this, especially if I'm using a 2-node cluster in things like hospitality or retail, where I have a large presence of small brick-and-mortar locations. How do I now manage it? I don't want to have 100 or 1,000 or even 20 of these deployments and have to think about managing them independently. And that's where Cisco developed Intersight. Now, when it initially came to market, Intersight was a SaaS-based solution, and that's still our preferred way of customers consuming it, and I'll speak to that in a minute, and that's what I'll be demonstrating. It can now be offered as an on-premises solution for those that have very strict compliance and security requirements and cannot use something that resides in the public cloud. But Intersight is a SaaS-based solution for providing centralized management of any UCS portfolio-based deployment. So whether it's traditional UCS, a standalone server, or it's Cisco HyperFlex, I can now have a single pane of glass to give me manageability and analytics of my entire Cisco UCS-based installation. So I get things like telemetry and analytics. I get inventory, and I can integrate this into my CMDB platform such as ServiceNow if I want to enrich the data and be able to tie together my ITIL processes with this centralized inventory of my entire compute installation base. It also affords me APIs to be able to start to integrate my UCS or HyperFlex infrastructure into broader automation initiatives. And because I am now basically proxying all of my UCS and HyperFlex through one system, I can connect that system with Cisco TAC for an improved connected support experience where metrics that are gathered, inventory information that's gathered, logs that are gathered through Intersight can be shared with Cisco as part of your support contract to, again, accelerate and reduce the time it takes to do root cause analysis and root cause remediation. So when it comes to HX Edge, where we have just a couple of servers and we have them out in a remote site, no fabric interconnect, again, I talked about the importance of having a witness so that we could determine when we have a split brain scenario. And that is what Intersight provides. It's a cloud-based service. These 2 servers out on your remote site, as long as they can dial home, they can then start to use this cloud-based witness service to ensure that we don't end up in a split brain scenario. And we can always maintain a true perspective of quorum within the cluster and knowing which nodes are truly up and which are down and which ones may just be appearing offline due to a blip in network connectivity or something else. So that cloud witness service is a key part of what Intersight provides. But more than that, it now provides us the ability to centralize the deployment of multiple clusters. Instead of needing to have UCS Manager in every site for me to use those service profiles locally to deploy, I can now push out policies and push out configurations and push down templates over the air from the cloud to hardware anywhere on the globe and then provision and then operationalize clusters across the globe. And we're going to show you some of that today. And what you'll also see is that this is not only the tool for provisioning and monitoring, it is going to be the tool for ongoing management, as you're going to be able to do full upgrades of the hypervisor, the firmware, and the software-defined storage layer, the HX data platform, through Intersight, and do that for one site or many sites. And that's what you see here. I want to be able to do non-disruptive upgrades. I could take advantage of the fact that the hypervisor is going to start to migrate virtual machines around and move my workload from one node to another, even in a two-node cluster, to where I can do non-disruptive rolling upgrades. And I can schedule those, and I can do them in parallel across many sites. So again, if you have a large install base, or if you're in a vertical where there's things like retail or hospitality, manufacturing, I can streamline and have parallelized upgrades where I'm monitoring this through a central point instead of having to focus on one site at a time. So with that being said, let's go on and do a demo, because I think this is going to be a lot more interesting when you get to see what is going on. So I'm going to share my screen here. And what I'm going to show you first, actually, what you see on the screen right now is the login screen to Cisco Intersight. I'm actually going to jump you over here and show you this one. This is going to be a heads Intersight that is running against our Chicago lab environment. And what you will see here in 1 second, you can do multiple accounts here, as you just saw. You can have a multi-tenancy approach to this platform. Now, this is the overall dashboard of Intersight for our Chicago lab. And as you can see here on this server inventory, I'm seeing here it's saying I've got 8 blades. That means traditional UCS, as well as 4 HyperFlex nodes. So I'm managing through this pane of glass both HyperFlex and traditional UCS. And you can see at the top here in this blue bar, it's saying new features have been added. And that's one of the benefits of having this as a SaaS-based solution, is that Cisco maintains this environment in a CI/CD, continuous development fashion. So new features are always being released, just like your apps on your phone. You log in, there's new features, new capabilities, new analytics being provided, new reports available to you for you to consume. And that's just, again, it's a managed solution. You're not having to do any upgrades or run any installation packages. You log into the system, these new features are there and readily available. So that's the dashboard here. I'm not going to use this one. We'll come back to this later, but I'm going to jump over here instead to look at Intersight as it pertains to HyperFlex Edge. So this is, again, deploying a cluster, a 3-node cluster, to a remote site where there aren't fabric interconnects. It's just connected to 1 gig switching, and I'm going to show you that process. So I'm going to sign in here. And when this loads up here, you're actually not going to see very much. And that is because we have not yet provisioned a HyperFlex cluster. You'll see here my inventory that's going to load up. And what you'll see is I have 3 servers. That's my 3 physical nodes that will make up my HyperFlex cluster. They're online and they're healthy. They've dialed home, and we've registered them here in Intersight. But I don't have any HyperFlex data. That's because we haven't actually yet, from the cloud, pushed down the provisioning and formed these 3 nodes into a HyperFlex cluster. That's why there's no data available. And similarly, if I was to go over to vSphere, you don't see anything right now. This is a vSphere installation, but there's literally nothing here in host and clusters view. No hosts and nothing showing. Now, for the sake of time, I'm not going to go through the actual live provisioning because, as I said, it takes up to 60 minutes. But what I'm going to show you here is that over in HyperFlex clusters, you're not going to see anything yet because I haven't provisioned the cluster. As you can see, that's blank. But service profiles. Now, this is the concept of a software definition of a server, what you would be used to if you're familiar with UCS Manager. And here I am creating one in Intersight. So I have created over here on the right a HyperFlex cluster profile. I started this process earlier because there's a lot of information that you provide. And again, this can be provided through an API or through a JSON file. Everything from naming conventions, versions, etc. Now, what I didn't do earlier is I didn't assign nodes. So I'm going to jump through here, and you'll see some of the information. I've already provided all of my configuration things in here, such as my DNS and my NTP settings, my vCenter configuration, so that it can register the cluster with vCenter. I'm going to skip all this, and I'm going to go ahead and I'm going to assign now those 3 nodes to this. So there's the 3 nodes that were here in Intersight. I'm now assigning to this profile. I'm going to hit next. It's going to do some validation here. And here it's pulled in the serial numbers for them. I'm saying, yep, that's what I want. And I'm now going to go ahead. Now, this is just saying here, this warning is nothing to be concerned about. It's saying that because this is an edge cluster with only 3 nodes, I can't get the same level of data resiliency that I could get in a larger cluster, where I would be able to stripe that data across a larger number of nodes. It's just warning me of that fact. I'm okay with that. That's by design. And I'm going to hit validate and deploy. And now it's pushing down over the air, over a TLS connection back to those nodes, this configuration. And it's going to keep running here, as I said, for about an hour. So I'm going to jump over to, here's one I made earlier. And if I go to Cisco Intersight, first of all, here, I'll log back in on this one. This time when it logs in, you'll not only see the 3 nodes, but you'll see the HyperFlex cluster. So it's just going to a minute to populate here. And now you can see here this column, I have my 3 servers like I did previously, but I also have now 1 healthy HyperFlex cluster. Okay, it's 1 cluster comprising of 3 nodes. Okay, and if I go over here on the left-hand side to my HyperFlex clusters tab that was previously empty, you can now see that I have here my edge cluster. It's running vSphere 6.5 update 2, and I get information in this pane of glass around storage utilization, version, whether it's healthy, as well as things such as utilization and optimization. Optimization being, what is the cumulative effective benefit of dedupe and compression. And I can see that I have 7.2 terabytes of usable space in here. I can also from here click on these 3 dots. Even though I'm logged into this central SaaS-based solution, I can click on these 3 dots and I can say launch HyperFlex Connect. And what it's going to now do is it's going to proxy a secure connection into that local cluster. So here I am now connected as if I was connecting remotely over the local area network to that cluster if I was on site. And this gives me a lot of the same information that was fed into Intersight. It gives me a little bit more information here, like its historical performance. I even get to see, the virtual machines. Since I'm tightly integrated with vCenter, I can tell you which virtual machines are running on this, and presently that's 0. We're about to change that. And I can see the health of each of the nodes here. If I hover over one, you can actually see the health of the individual disks. Now, if I jump up here to the vSphere client, previously I had said that there was nothing in the hosting clusters view. But if I go over there now to my hosting cluster view in vSphere, you'll see now I have a cluster created, a vSphere cluster, and that is my 3 HyperFlex edge nodes. And as we talked about earlier, you're going to see 3 virtual machines. That's the storage controller VM. Again, one of these is local to each physical host, pooling that data into that software-defined storage layer. But there's no other VMs running, and if I go to data stores here on the right, you can see there's 3 data stores, but that's just the local data store for each host where that storage controller VM is running. I want to provide now the distributed shared volume for my workload VMs. Now, I could do that through HyperFlex Connect, but typically I'm going to use the integration with my hypervisor. So here in vSphere, it actually integrates itself. So if I go to global inventory lists, as part of that provisioning process, I now have HyperFlex data platform and HyperFlex systems down here in vCenter. So if I go here, I will actually see my cluster. So it's going to show me one cluster in a minute when this GUI refreshes. So here's the edge cluster we provisioned from Intersight. And if I click on this and drill down into it, I can now see, go into manage, I can do additional tasks in here. So if I go to, here's my cluster information, each of the hosts, I get a view on them, how many disks, how many persistent disks, how many caching disks, et cetera. But I can go to data stores in here and I can see the data stores, which will presently be none because the HX data platform is not providing any. So I'm going to create one. So I go here and I click on this plus sign, and I'm going to create a 1 terabyte or 1,000 gig. I can change this to a terabyte if I wanted to. Okay, so we'll leave it at 1,000 gigs for now. And I'm going to call this webinar 1 as my data store and hit OK. And it's creating down here, and it's already done, created the data store. Now you'll see it says creating a NAS data store because the way in which HyperFlex provides the storage to each individual node is through NFS, right? The IO visor component of each of the storage controller VMs is using NFS to distribute services to the nodes. So now if I go back to my traditional view, my hosting clusters view, and click on any one of these nodes, I can now see this webinar 1 is a data store that is presented here and accessible from all 3 of the nodes. So let's go ahead and deploy a virtual machine. I'm going to deploy from an OVS template that I have residing here on my workstation. So I'm just going to browse to that quickly. We'll deploy the smaller CentOS template here for the sake of time. And I will call it CentOS server. I don't mind where it resides, so I'll just tell it to reside on the cluster. Once it's validated the OVF file here, it's going to ask us for some information about where we want it to be provisioned. So I'm going to select that newly provisioned HyperFlex data store. So it is going to go on my webinar 1 data store. And I want to make sure that I put it on the appropriate network. So let's put it on the VM network for now. And I'm going to go ahead and provision this. So it's now spinning up an actual workload VM on top of my HyperFlex cluster. And we'll give it here just a minute or so for it to finish deploying. And what you'll see as soon as that finishes, if I go back over to HyperFlex Connect, this number here will increment shortly once this refreshes. And you'll see that there is a virtual machine on here. So there you go. As I drill down, there's my CentOS server. And you can see that it's 11.2 gigs of provisioned storage. It's actually using 10 gigs, and that's because I told it to thick provision, but you can see it's already optimized about 1.2 gigs through the inline dedupe and compression. Now, as soon as this finishes deploying, I will power it on. It's at 61% right now. Okay, it's completed, so we can power this on. And now, one of the last things that I want to demonstrate to you is one of the benefits that you get from HyperFlex Data Platform, and that is because it's tightly integrated with the hypervisor, and it is an object-based file store, I can do things like snapshots and cloning very, very efficiently. So I can create new virtual machines by basically instantiating pointers on the storage and not actually having to copy any blocks. So if I go down here now and click on my CentOS server, I can go down here to Cisco HX Data Platform, and I can say ready clones. And I want to have 10 clones. I'm not going to worry about doing customized specs right now. That's obviously, if you're familiar with VMware administration, that's allowing me to do things like change the SID of a Windows server or change any of the specific information about the instance as it gets cloned. I'm not going to worry about that for the purpose of this demo. I want to give it a prefix, so we're going to call it webinar, and we're going to start it at 1, and we're going to increment it by 1. So we should be creating webinar 1 through 10, and we're going to power them on after cloning here. Okay, and I'm going to hit go. And behind the scenes, it is doing a HyperFlex snapshot, and then it is going to turn those into ready clones. And you will see here, there it's taking one as its parent image, and immediately there's 10 VMs, and they're already up and powered on. So as you can see, the time it took for that to complete was extremely fast because it's not doing any actual copying of data. It is now on the back end in the storage layer tracking pointers individually for each of those VMs. So I went from having 1 VM to having 11 VMs in about 3 minutes, and they're already powered on. So that is some of the value you get from the software-defined storage layer that you get with Cisco HyperFlex. I can snapshot I can clone, and if I have multiple clusters, I can replicate. And for every single bit of data that is written to the platform, it is compressed and deduped. So if I go back over to HyperFlex Connect and go back to my main screen here, my dashboard, you'll now see when it refreshes, it hasn't yet refreshed to say that there's more than one virtual machine, but you can see I'm starting to get information about consumption. It's going to take a few more minutes. This is a new cluster before it starts to show me the storage optimization information. But again, if I drill down, I can see, there you go, webinar 1 through 10, the virtual machines that are now running on this platform. So with that being said, we've demonstrated Intersight as this centralized SaaS-based application for looking at not only inventory and health of our UCS and HyperFlex deployment, but we've also shown that we can create service profiles and templates and push down over the air to remote sites and have clusters built using essentially Intersight as the equivalent of UCS Manager and doing service profile creation. And we've demonstrated how we can deploy VMs very quickly and then clone them on top of a Cisco HyperFlex platform. So that concludes what I wanted to cover here in today's demo. So we're going to move on to taking some of the questions that have been submitted. And the first one up here is, can we use more than vSphere as a hypervisor? Yes, I think I briefly touched on that earlier on. HyperFlex does allow you to use both VMware vSphere or Microsoft Hyper-V as your preferred hypervisor. And that, again, is one of the differentiators of the solution, that you're not tied into using a component of the hypervisor itself. It's not, for example, VMware vSAN, where you have to have, obviously, vSphere as your hypervisor of choice in order to consume that solution. Looking through here, I have another question that says, can we use non-HyperFlex nodes and use the same storage? Yes, you can. So with HyperFlex, it is possible for you to present the storage layer that is that pooled storage across your HyperFlex cluster. Okay, you can present that, again, it's NFS3 based, to non-HyperFlex, what become known as compute-only nodes. So you could have B-series blades, you could have C-series servers that can consume the storage that's provided by the HyperFlex cluster without needing themselves to have local disk. And we see that commonly for just scale, from a cost-effective solution. If I don't need additional nodes with disks in, but I need more memory and compute for my workload, then that's a very effective way of doing that. Or if we have some specific workloads, for example, AI and machine learning, or VDI, where we want to have nodes that are dense in things like GPUs from NVIDIA, then we would use those nodes as separate nodes consuming that storage provided by HyperFlex, but they themselves are not participating in the storage layer. Okay, well, it doesn't appear that I have any other questions coming in. I see one more. No, that one we have already addressed that one. So thank you very much for that question. Well, I appreciate everybody who's jumped on today and joined. I hope this has been helpful. If you would like to follow up on anything we've discussed today, I would be happy to schedule a follow-up meeting, go into a deep dive on anything that we've covered here today, whether that's traditional UCS, HyperFlex, Core, or Edge, or Intersight. Again, I'm a strong believer that what Cisco has provided here in this centralized management through Intersight of both traditional UCS and HyperFlex is extremely compelling. And some of this stuff that I know is coming down the pipe, and what they're going to use the automation orchestration capabilities of Intersight to provide is going to drive a lot of value in our customers. So I'm excited to see that. And again, thank you for your time today. Thank you for taking an hour out of your day to join us here on AHEAD's webinar. Thank you.